Today we are going to see Rule 3 for finding the particular integral. Where in Rule 3, how you are going to decide the Rule 3? By seeing the q of x. When your q of x is in the form of x to the power of k, where k is a positive integer. K is a positive integer. The formula for writing the pi is equals to 1 by f of d into q of x, where f of d is a polynomial equation in D, and q of x is equals to x to the power of k. Where we are going to reduce this f of d in the form of 1 plus or minus phi of d by taking out the lowest degree term. Where 1 by f of d into x to the power of k will get reduced to 1 plus or minus phi of d x to the power of k. Now we will take 1 plus or minus phi of d to the numerator. It will get reduced to 1 plus or minus phi of d whole to the power of minus 1 x to the power of k. Now we are going to open this 1 plus or minus phi of d whole to the power of minus 1 by using the binomial expansion. After opening the binomial expansion, we are going to operate this x to the power of k to each and every term of the bracket. Where frequently we will be using the binomial expansion as it is a important formulas. The problems will be based on this binomial expansions only. First one, 1 by 1 minus d, where we can write 1 minus d as 1 minus d whole to the power of minus 1, and we are going to take it to the numerator. Now we can open it as 1 plus d square plus d cube, so on. The second one, 1 plus d minus 1, it's equals to alternative terms 1 minus d plus d square minus d cube plus so on. The third one, 1 by 1 minus d whole square, it's equals to 1 minus d to the power of minus 2, it's equals to 1 minus 2d plus 3d square plus 4d cube, so on. 1 by 1 minus 1 plus d to the power of 2, it's equals to 1 plus d minus 2, it's equals to again alternative terms 1 minus 2d plus 3d square plus minus 4d cube, so on. 1 by 1 minus d to the power of 3, it's equals to 1 minus d to the power of minus 3, it's equals to 1 plus 3d plus 6d square plus 10d cube, so on. 1 by 1 plus d to the power of 3, it's equals to 1 plus d to the power of minus 3, it's again alternative terms. 1 minus 3d plus 6d square minus 10d cube plus so on. These 6 formulas we are going to utilize for solving the problems. You have to by heart these formulas, then only we can solve the rule 3. Just make a note of this one. Now let's see one problem. Solve d square plus d plus 1 into y is equals to x cube. By seeing that x cube, we will get an idea. The problem has to solve by using the rule 3. Now first we'll write auxiliary equation where d will get changed to m square plus m plus 1 is equals to 0. This is in the form of quadratic equation. By common factors we cannot find, so we will use the formula minus b plus or minus under root of b square minus 4ac divided by 2a, where values a is equals to 1, b is equals to 1, c is equals to 1, minus b minus 1 plus or minus under root of 1 square minus 4 of 1 into 1 divided by 2 of 1, it's equals to minus 1 minus 3 divided by 2, where minus 1 value is equals to I, minus 1 plus or minus I root 3 by 2. So the roots are complex roots. The roots are complex roots. So the complementary function is equals to y suffix c is equals to e to the power of alpha x into c1 cos beta x plus c2 sin beta x, where this one we can write minus 1 by 2 plus or minus I root 3 by 2, where minus half value of alpha and root 3 by 2 is the value of beta. Y suffix c is equals to e to the power of minus half x c1 cos root 3 by 2 x plus c2 sin root 3 by 2 x. This is known as complementary functions. Half of the problem is completed. Now we have to find the pi. Pi is equals to 1 by f of d into q of x, where f of d is the given polynomial in the terms of d, where q of x is equals to x cube. By seeing this x cube, we can decide the problem. The pi has to be solved under rule 3. D square plus d plus 1 into x cube. We will reduce this d square plus d plus 1 in terms of 1 plus or minus phi of d, where the lowest term in this, it's a 1. It's equals to 1 plus d square plus d into, this is known as your phi of d, into x to the power of 3. Now we will take this term to the numerator. It will get reduced to 1 plus d square plus d whole to the power of minus 1 x cube. We know that 1 plus d to the power of minus 1 is equals to 1 plus d square minus d cube plus so on. Where d is nothing but your d square plus d. After opening by using the binomial expansion, we are going to multiply that x power 3 to each and every term, plus d square plus d whole square minus d square plus d to the power of 3 plus so on. Why I have stopped it there by cube only? Because the power of x power 3, it's a 3. Based on that, we are going to write that binomial expansion terms. Now we will open it by using a plus b whole square formula. D power 4 plus 2d cube plus d square by using a plus b whole cube formula. D power 6 plus 3 d power 5 plus 3 d power 4 plus d power cube, then x cube. We will solve first that terms in the bracket only, then later we'll operate with x power cube. 1 minus d square minus d plus d power 4 plus 2 d square d cube plus d square minus d power 6 plus 6 power 5 plus minus 3 d power 4 minus d cube x cube. Where the highest terms will get vanish, because d cube x cube it's equals to, where d stands for d by dx. First time differentiation we will get 3x square, d into d square into x cube it's equals to 6x, d cube x cube it's equals to 6. D power 4 x cube is equals to 0. The remaining terms, all the terms will vanish when we are going to do number of differentiations. Now what we left, 1 minus d square, the d square and d square will get cancelled. D square then plus d square will get cancelled, and where 2d cube and minus d cube. So we are left with 1 minus d plus d cube then into x cube. Now we will operate this x cube to each and every term of the bracket. X cube minus dx cube plus x cube into d cube. X cube dx cube value is equal to minus 3x square, and d cube into x cube value is equal to 6. Now general solution, where general solution is equals to complementary function plus particular integral, where complementary function is equals to e power alpha x of c1 cos √3 by 2x plus c2 sin √3 by 2x x cube minus 3x square plus 6. Here this is known as your complete solution under a rule 3, and where I have not written here alpha value it's equals to your minus